friends, we have started discussion and our learning of properties of fluids. In the previous video, we discussed that velocity, acceleration, speed, acceleration due to gravity. Of course, they are fundamentals. Okay, coming to that properties of fluid. Why you have to learn these properties of fluid and in which condition fluid is there, how that fluid exert the pressure, because of that pressure what are the stresses that are induced. All these things we can learn here. If you see that in the fluid mechanics, fluid behavior at rest and motion is needed. So when fluid in rest and motion, we have to understand their behavior. In fluid mechanics we have to understand. Then coming to that, the study of the fluid at rest is called fluid static. Suppose you take the water tank. The water tank is generally constructed top of the buildings, so that the tank is filled with water. Once so that is in static condition. Static condition means that tank in rest condition, that tank is filled with water, so that water exerted the pressure on tank walls as well as in the downward direction, so that what is the thickness, suppose what is the volume of water, because of that volume of water what is the pressure that is exerted, that to sustain that pressure what is the thickness of the wall and what is the material that is required to sustain that pressure. All these things to learn, that is called fluid at rest is called fluid static. Next the condition fluid, the study of fluid at motion where pressure force are not considered is called fluid kinematics. Obviously the fluid exerted pressure forces, and of course when it is in motion, obviously we have to consider the acceleration, velocity of the fluid and the pressure forces that are coming into the picture, those things to be considered. But in this case the fluid at motion, suppose if you are not considered pressure forces, only you considered other things, velocity, acceleration, those studies is called fluid kinematics. So fluid kinematics, fluid in motion, but we don't consider the forces, pressure forces. Obviously when fluid is in motion, obviously the force is exerting by that fluid, and it has some velocity, it has some acceleration. All these things are discussed, but the pressure forces are not considered. Rest of the things are considered. That study is called fluid kinematics. Okay, suppose you take canal. If you take a canal or during that through that canal the fluid is taking place. So the forces is not considered, only the motion is considered. Rest of the parameters, that study is called fluid kinematics. Okay, next one is fluid, the study of the fluid at motion where pressure forces, all the things, whatever the things are causing the fluid get motion, that study is called fluid dynamics. So in these three cases you have to understand the fluid behavior, that is needed in the fluid mechanics, okay friends, coming to fluid properties. So if we have to understand fluid behavior at rest in motion, First we have to understand the properties of that fluid. Properties of that fluid. So unless you understand the properties of the fluid, we cannot calculate, we cannot understand when a fluid is rest, what are the pressures, what are the pressure, what are the pressure that is exerted, and we cannot design the anything. If you want to design the water tank, we have to understand these properties of the fluid. We have to design the canal, we have to understand these properties, and of course the water tank is at higher elevation, so through that we connect the pipelines to convey water from that tank to required places in the building. Obviously they can exert pressure on the pipelines, so therefore whenever water is using for different situations, static and in dynamic conditions, before that we have to understand that properties of that fluid, then only we can design the water tank, or to convey that water, the pipelines, and all these things we can design. That is the most important. In simple way to understand intermediate student or 10th class student, suppose any matter, any material, material, that properties we have to understand first. Then before that material is going to be used for different purposes. For example, students, 10th class students, you understand, 10th class students, suppose your friends are proposing to go for movie tomorrow. Of course, the tomorrow is a working day for your school. One student, he told that my father may not be accepted this proposal to go for movie. He telling that his friends. Why he is telling that thing to his friends? Because he knows his father characteristics. His father is may not accept during the working hours, working days of the school. Then he knows his father character. That's why he is telling that my father he may not be accepted. So that he knows his character, his father character. Then he telling that my father may not accepted my request. So that therefore, in the same way, we have to understand the any material, not only fluids, any material is using for various purposes. So before that, using that material characteristics and our properties should clearly understand. Then only we can effectively using that material for that particular purpose. Okay. Coming to that fluid properties, these are the properties: weight, force, mass density of the fluid, weight density of the fluid, specific gravity of the fluid, viscosity of the fluid, surface tension, and capillarity. So these are the properties we are going to learn. Okay, first we can understand the weight. Of course, last video we learned about the velocity, acceleration, speed, acceleration due to gravity. The weight equal to weight of any, maybe it may be we are talking about fluids, so weight of the fluid or the solids, mass into acceleration due to gravity. So therefore mass is denoted by, okay, mass m into g is denoted by, mass is denoted by m, acceleration due to gravity is denoted by g. So therefore weight equal to, so we can denote it by capital W. So W equal to m into g, mass into g. G, so units equal to mass in kgs, g equal to G equal to meter per second square. Meter per second square. This is equal to, so therefore kg meter per second square. Kg meter per second square. Okay. Okay. Next, for example, we can take a simple model. Suppose mass equal to 10 kgs. We know that G equal to 9.81 meter per second square. We have to remember this value. So therefore find out weight. This is equal, find out weight. So weight equal to we know that mass into acceleration due to gravity. So mass equal to 10 kgs into acceleration due to gravity equal to 9.81 meter per second square equal to, so therefore multiply 10 into 9.81, so that this is 98.1 kg meter per second square. This is the weight. Of course, weight and mass generally, weight and force, the units equal to newtons. So therefore this is equal to 98.1 newton. 1 newton. Coming to that Newton means, of course, 1 kg meter per 1 kg meter per second square equal to 1 newton. 1 newton. So therefore 1 newton. So this you can understand here. Next we will get a detailed discussion. Next we are discussing the force. So this is the weight. Weight equal to mass into acceleration due to gravity. Let us say that in this problem mass equal to 10 kgs, G equal to, we know that 9.81, we have to remember that. So therefore 10 into 10 kgs into 9.82 meter per second square, this is equal to 98.1 kg per meter per second square. So 1 kg meter per second square equal to 1 newton. So therefore this is equal to, if you convert into newton, so 98.1 newton. Next term is so here from this problem you can understand here, this is the weight, mass is the equation. Weight equal to mass into acceleration. Suppose they will give weight and weight, we can find out the mass. So mass equal to mass equal to weight by G. From this equation we can find out, because G is constant, we know that 9.81 meter per second square. So that from this equation, if you give the weight, we can find out the mass. By using this equation. Okay, next term going to force. Force is defined as the product of mass into acceleration. So the units equal to again kg into meter per second square. This is equal to kg meter per second square. This is also 1 kg meter per second square equal to 1 newton. So what we can understand here? That force is exerting 1 kg of mass object moving with 1 meter per second square acceleration. 1 meter per second square acceleration. So therefore, this 1 kg meter per second is 1 Newton. 1 kg meter per second square is equal to 1 Newton. Of course, if you observe this, the force and weight, they are getting same units. They are equal to kg meter per second square. Here also force, mass, weight is also kg meter per second square. Weight is also converted into Newtons, so they are also Newtons, so this force is also Newtons. But what is the difference between the force and weight? Of course, coming to that force, different types of forces are there. Contact force, frictional force, shear force, and force. This is one kind of force. So therefore, the force and weight, if you clearly understand that weight means mass multiplied with acceleration due to gravity. Whereas force, you are coming to that mass into acceleration. So in the force and weight, the thing is difference is here. Of course, you are getting the same units, but thing is that here is acceleration due to gravity, whereas here only acceleration. I already explained previous video what is acceleration due to gravity and acceleration. Acceleration due to gravity is related to the earth. Suppose if you thrown up a object, that object is falling down, because of acceleration due to gravity, earth has magnitude, so that it has a pulling that object downward direction, so that it has some acceleration due to gravity. That value is 9.81. It was already calculated. So that weight and force, the difference is in the weight, acceleration due to gravity, whereas in force, acceleration. That is the difference. Of course, they have same units. One more thing here, 9.81 newtons equal to 1 kgf. 1 kgf means here 1 kg meter per 1 meter per second square is equal to 1 Newton. So 1 kgf and 1 kg force equal to 9.81 newtons, or 9.81 newtons equal to 1 kg force.